Right. Now, take tutorial 3. Okay. Take tutorial 3. I want to start discussion of tutorial 3. Let me open the chat window as well. Right. Good. Okay. Now, I will start from 2006. Right. 2006 question. Tutorial number 3. This one. Right. Tutorial blur. It's blur. Tutorial number 3. Right. Okay. Number sixth question, 2006, right? I will go through the others as well. Let me start from 2006. The color imparted on the Bunsen flame by metal atoms results the light energy released when electron return to the ground state. Energy E equals 0. Energy equals E0. From the first excited state, energy equals E1. The flame colors of some atoms are given below: lithium red, copper green, sodium yellow, potassium violet. The correct order of E1 minus E0 for the atom is. This is a very good question, actually. A good question, this one. So let me explain about the Bunsen burner or Bunsen flame test, right? So, Bunsen flame test or flame test. Flame test is used to identify the metals. How they identify metal is by using the color of the flame. They are taking small amount of metal. It can be potassium, calcium, cesium, or anything, and mixed it with some kind of salt solution, or simply mixed it with salt. Then slowly move it to the Bunsen burner flame. Bunsen burner is something like this. This is available in the laboratory conditions as well. There is a gas inlet here, and we have flame here. And when we take closer a kind of a strip, and with the subjected metal dissolved or added with some salt solution, then this item will start to burn. This item will start to burn. Then different colors will be starting to produce. So these colors are given in this question. So when you use lithium, lithium is giving out the red color. These are in detail. These are discussed in detail in S block, but S block knowledge is not needed for this one because the colors are given. So lithium, they are given. It is giving out a red flame or red color flame. I will share you a video to check this one. Then copper, it's giving out a green color. Then sodium is giving out a yellow color. Potassium is giving out a violet color. Now, if I give you some other examples, cesium, it gives out sky blue color. Then barium, apple green color, or simply green color, light green color. Then calcium, brick red color. So these are flame test colors, and these are used to identify these metals as well, because identification of metals cannot be done very easily by using chemical reactions. P block elements and D block elements can be identified by using the chemical reactions, but not that much easy to identify the S block elements by using chemical reactions. Can be done, but flame test is one of the popular method to identify the S block elements. How they use it, they take a small amount of metal and mix it with a, salt solution and start to burn. Then while it is burning, it is giving out different colors. That's the idea, right? Uh, it is the color of the flame, right? Very nice colors. So when you do the barium test, it's a very nice color, like the apple green color, right? How this is happening is can be identified or can be explained by using unit one knowledge. What is happening there is when the burning means you are supplying energy, heat energy, right? Energy in terms of heat will be supplied. So it will be absorbed by the atoms. When energy is absorbed by the atoms, not the protons, but the electrons will start to move, right? Protons also can be moved, but it needs a high amount of energy. So comparatively, electrons can be moved very easily. So supplied energy will be absorbed by electrons, and it will be moving to the high energy levels, from low energy levels to high energy levels, right? So when we take it out from the Bunsen burner, then energy supply is disconnected. Then electrons will move from high energy levels to low energy levels. You don't need to disconnect the energy source sometimes, because some electrons, if they are not receiving the sufficient energy continuously, they will start to move from high energy levels to low energy levels. When they are moving from high energy levels to low energy levels, they are releasing energy. While they are releasing energy, they will adhere to E equals h nu equation. So what happens is, like, first they will move from low energy levels to high energy levels. This is energy absorption. These are electrons are moving from low energy levels to high energy levels. Let's say, as this is given, this is E bar 0. This is E bar 1. Let's say these are notations. Then energy is not supplied, sufficient energy is not supplied, then they are moving from high energy levels to low energy levels. So they will move like this. Electrons will release energy to move into the low energy levels. Then this E will matching with h nu. If this nu is in the nu means the frequency, h means the Planck constant, E is the energy, right? So this is the energy of one photon. So photon is whatever the energy released by one electron. It is a quantumized one, right? So E is the energy, H is the Planck constant, and nu is the frequency. So if this nu is in the visible range, the light is also a frequency, right? If this is in the visible range, it gives out a color. It gives out a color, right? So based on the element characteristics, the energy absorption or energy releasing amount of energy released will be differed. That is the element characteristics, right? So if the element is can absorb high amount of energy, depends on the characteristic, it move into some higher energy levels, and it is moving from high energy levels to low energy levels, so it is releasing high amount of energy. If it is releasing high amount of energy, since E is directly proportional to nu, it start to release the a frequency which has high frequency, or like higher frequency, right? I will explain it again. When the amount of energy absorbed by each and every element is not equal, it depends on the energy, it depends on the element characteristic. So for an example, let's say lithium is absorbing lower amount of energy, and potassium is absorbing high amount of energy. Let's say for an example, let's say. So lithium moves into some, let's say n equals 1 to n equals 3 or somewhere around that one. Potassium will be moving into n equals 1 to n equals 5 because it can absorb high amount of energy. අර එක එකට කන්න පුළුවන් කාණක් තියෙන ලිතියම්ට පොඩ්ඩයි කන්න පුළුවන් potassiumට ගොඩක් කන්න පුළුවන්. එතකොට then it is moving into the high energy level. Then they are moving from high energy levels to low energy levels. They are releasing high frequency because E directly proportional to the new lithium lower frequency. So likewise, that's how the each and every element is giving out a different color, right? So now in this question, so this is the background of this question, right? Because I have to explain the background of the equation or background of the question because you don't know about the flame test. That's the reason, right? So the lithium is red, and copper is green, sodium is yellow, potassium is violet. So correct order of E1 minus E0. That means the energy change in each and every element when it is moving from high energy levels to low energy levels. E1 is the high energy, E0 is the ground state, right? මම කියලා දුන්න මොනවද මේ ground state and excited state කියලා කියන්නේ මොනවද කියලා. Ground state means the lowest energy level. Excited energy means high energy levels, which to which they are moved from low energy levels to high energy levels. So these are excited states. After absorbing energy, they are moving into the high energy levels. That state is called as excited state. So when it is moving from excited state to ground state, they are releasing energy. So which means it is generating a emission spectrum. ඒවත් මතක් කරගන්න ඕනේ. So generally, if we are seeing a color, it is generating a kind of a emission spectrum. If it is absorption spectrum, we can't see anything, right? I'm saying if you are checking the flame test, right? So, and also we know in the visible range how the colors are and what are the colors and their the frequency difference. So let's say we are starting from red, and we will have violet. Sorry, we will have violet. We will have indigo, blue, green, yellow, oxygen, and red. So even though I have drawn the red lines, this is a continuous one. You know about this one, right? So in this one, from red to violet, lambda is decreasing, frequency is increasing, energy is increasing. This is the base, right? Energy is increasing, frequency is increasing, and lambda is decreasing, right? So if I match these colors, so lithium will be somewhere around here. This is red. Copper will be somewhere around here. And sodium will be somewhere around here. And potassium will be somewhere around here. So the highest frequency is released by the potassium. So potassium should have the highest energy difference because of this relationship E in directly proportional to the frequency. That is the direct relationship, right? So highest energy or highest energy difference, that means E subs E dash 1 minus E dash 0. This is the energy difference. If you take this one, this energy difference is highest in potassium because it is having the highest energy level, or it is having the highest frequency, right? Because E directly proportional to the nu. Then we have copper, then we have sodium, then we have lithium. So sorry, other way around. This one should be potassium is the highest, then sodium, then lithium. So in this direction, frequency is decreasing, energy difference is also decreasing, the lambda is increasing. So the correct answer is fourth one: potassium, copper, sodium, and lithium. Right? So this is a combination of S block and the unit one, but just by using the knowledge of unit one, you can get the answer. Right? මම notes දෙන්නේ. I'm not giving you the notes. You understand the logic, right? Because the note has been given in your theory note. In your theory note has been given. So you understand how the approach of the question, and how I derived the question, how I understood the question, and how I have taken the answer. ඔක තමයි important day. එතන මම කියන දේ තේරුම් අරගෙන ඔයාලගේ භාෂාවෙන් in your words you write your answer, right? So that's how it should work. Otherwise මම මේකට note එකක් දීලා ඒක පාඩම් කරන්න කියන එක ඒක හරියන්නේ නැහැ. So you have to understand the question, and you have to understand the approach, and you have to write down in your own words. මේකට මේ උත්තරයට ඉරක් ගහගෙන නම් මේක නවත්තන්න එපා. හරිද? ඒක මට කියන්න දරන ඉස්සර වෙලා. දැන් මේ ටියුට් එක ගත්තාම හරිද? When you take this tute, I'm discussing each and every question. Sometimes I will skip some questions for you because you can do them. So you take some rough papers, right? Like this. You take some rough papers and put number 1. Or like this is number 6. A theory. Right? What is the use theory? Right? Or the background of the question. Like there is a Bunsen burner, and Bunsen burner is giving out different colors, and these are the colors, right? So these are the colors. Lithium is red. So these are some additional information. Sometimes I will be explaining some theories which has not been done in the theory class, which will be done in the upcoming sessions. But if it is needed in this question, I will be explaining those theories as well. So that's okay. So you write down those things as well. So due to this reason, the approach should be like this. So the potassium is giving out the violet color. Violet color is giving out the highest frequency. So therefore the potassium should have the highest energy difference between the ground state and the excited state. So you can explain that this color is due to the emission spectrum when it is moving from high energy levels, low energy levels. When energy is applied or supplied, heat is absorbed as an energy, and it is moving from low energy levels to high energy levels. So when energy is disconnected, it is moving from high energy levels to low energy levels, while energy is releasing. When energy is releasing, if the frequency is falls in the visible region, then you can see a color. ඔය කතන්දරේ ලියන්න ඔයාලගේ භාෂාවෙන්. හරිද? ඒක පිටු භාගයක් ගියත් කමක් නැහැ. ඔක ලියන්න. ඔක තමයි පාඩම් කරනවා කියන්නේ. හරිද? මේක දිහා බලලා උත්තරේ ගන්න එක නෙමෙයි. මේක ලියලා you have to ඔක ලස්සනට ඕනේ නැහැ. right? පොඩි ස්කෙච් එකක් ගහලා එහෙම ලියන්න ඔයාගේ භාෂාවෙන්. ඊට පස්සේ මේක ලියලා ඉවර වෙලා you write your own theories or notes in the rough paper. So මොකක් හරි එක පොත්වල ලියන්න යන්න එපා වැඩි. හරිද? කොලේ කරගෙන ලියලා මේකට ක්ලික් කරන්න. right? මේකට ක්ලික් කරන්න. Then once you go through the theory, once you go to the tutorial again after 2 months or 6 months or 8 months, then whenever you forget the theory, when you forget how you taken the answer, you have your own note. You can check how you derive the answer. That kind of commitment is needed for this one. So this is how you do the MCQ questions, not underlining the correct answer. That will not work, right? So this is how MCQ works. After you are very solid with the MCQs, that's okay. But once you do the questions while you are learning the theories, this should be done. once you start to do the papers and once you start to do full papers, no need to do this one. But at this stage, you have to do this. Make a ලියලා මේකට click කරන්න. Right? This is how you uh, take how you do the MCQ questions. ඒක පොඩි MCQ එකක්වත් කමක් නැහැ. ඉස්සර මම පණ දාගෙනම ලියනවා. Right? That's ඒක කොයි වෙලාවකත් අපත යන්නේ නැහැ. Right? Because you will recall the theories very easily. Okay. Right. Next one, number 7, 2006 question. So in total, previous question is also 2006. This question is also from 2006. So 2006 has, next question is also 2006. Now, this question, if you check the previous question, it is having 5 choices, right? 1, 2, 3, 4, 5. But in the 7th question, if you check the 7th question, there are 4 choices. They are measured. They are given as A, B, C, D. So these are tricky questions actually, right? So how you get the answer if A and B is okay are the answers for the given question, then the correct answer is number 1. If B and C is correct or okay for the given question, then the answer is number 2. If C and D is correct, number 3. If A and D is correct, number 4. If any other choice, it can be 1 or it can be either A, it can be either B, C, D, or A, B, C, D, or like B, D, right? So those are number 5. Any other choice? Any other choice, you have to select 5th answer. Right? So this is how you do ABCD questions. Make a බේත් වට්ටෝරුව වගේ මතක තියෙන්න ඕන. AB correct number 1, BC correct number 2, CD correct number 3, AD correct number 4, any other choice number 5. මේ මේ A level වල instructions බල බල මේ බලන්න මේවට වෙලාව තියාගන්න ඕනේ නැහැ because these are common things. It's okay to remember things as well. මම පේපර් කරනකොට ඕන තරම් මතක තියෙනවා. මම මේක දැන් කියලා දුන්නේ මේක මම කරන පළවෙනි ප්‍රශ්න නිසා. So if AB is correct, the answer is number 1. BC number 2, CD number 3, AD number 4. So this is how you do this question, how you select the answer, right? So මේවා හරි carefully මතක් කරගන්න ඕනේ. ඒ කියන්නේ මේ question එක බලනකොට හරි carefully මේක මේ තේරුම් ගන්නවා. හරිද? දැන් අපි ප්‍රශ්න කියමු. This is a statement questions, right? Statement question means it will be testing your theory knowledge, right? There are no usual ABCD questions are theory questions, no calculation questions, right? Now, which of the following statements are true? Are true. So that means there can be more than one, or it can be only one. They are not saying it is one or more than one. That's why it is given as are true. On the true way වත හොයන්න ඕනේ. සමහර ඒවා තියෙනවා not correct, not true. එතකොට හොයන්න හරි ඕනේ වැරදි ඒවා, right? ප්‍රශ්න කරනකොට බලමු අලුත් ප්‍රශ්න. එහෙම තමයි ඒතකොට වැඩේ යන්නේ. හරිද? So A, Bohr theory is a nuclear model of the atom. අපි ඔක්කොම කියමු. හරිද? Rutherford proposed the first nuclear model of the atom. Number C. So C. Electrons do not behave as waves and particles at one and the same time. Electrons do not behave as waves and particles at once at once and the same time. EOM ratio, ELM නෙමෙයි. EOM ratio මේක හදාගන්න. EOM ratio of the cathode rays varies with the gas inside the cathode ray tube. Statement හතරක් දීලා තියෙනවා. There are four statements. Right? Now let's check D, right? D means EOM ratio of the cathode rays varies with the gas inside the cathode ray tube. That is wrong. D is wrong because EOM ratio is a constant value irrespective of the gas used inside the cathode ray tube. So D is incorrect. Let's check C. Electrons do not behave as waves and particles at once and the same time. That is also wrong. Electrons behave as waves and particles at the same time. So that's why electrons can show wave particles and as well as wave characteristics and as well as particle characteristics. While they are moving, they can create some kind of momentum, and also it is having a frequency as well, and it is generating some kind of energy as well, right? So having a momentum shows you that it has the particle characteristics, and having a frequency or lambda shows you that it is having a wave characteristic. So at the same time, at once, it is showing wave and particle characteristics. So C is also not correct. B, let's say B. Okay, A, B, C, D විදිහට ගියත් කමක් නැහැ. මම මේ අහුවෙච්ච තැනකින් මම මේ පටන් ගත්තා. Rutherford proposed the first nuclear model of the atom. This is correct. Geiger Master, Rutherford, that experiment brought out the idea of the nucleus, right? So Rutherford is also there. So that's how the idea of the nucleus came out to the world. So Rutherford proposed the first nuclear model of the atom. This is correct because in Thomson's model, Thomson has a plum pudding model. There is no such thing called as nucleus in the Thomson's one, right? So, but Rutherford gives you the first idea about the nuclear model through the gold foil experiment, right? So B is correct. This is B. A. Bohr theory is a nuclear model of the atom. Bohr theorem is also gives you the idea about the nucleus, because in the Bohr theorem they are saying the electrons are rotating around the nucleus. So that is also accepting the nuclear theorem, right? So what Bohr is saying that Bohr gives us the idea about the energy levels as well, and electrons are moving around the nucleus. So it is also a nuclear model. He is not saying that atom is not having a nucleus. It is having a nucleus, right? That මේ වගේ ප්‍රශ්න තමයි අහන්නේ. Now Bohr is saying that there are energy levels and electrons are moving around the nucleus in the minimum energy when energy is not supplied and it is rotating around the nucleus. So it is not rejecting the nucleus concept. Bohr theorem is also a nucleus concept, right? So A is also correct. So A and B correct means in our theorem or in our this choice selection, first one answer should be the first one. දැන් මේක එක දාගෙන එහෙම නතර කරන්නේ නැහැ. මේක ලියන්නේ මෙහෙමයි. මෙහෙම ප්‍රශ්නේ උත්තරේ දැම්මා number 7. A කියලා දැම්මා. Bohr theorem. පුළුවන් නම් Bohr theorem එක මෙතන ලියන්න. Write the Bohr theorem again here. It's okay to check the notes as well. So you will go through the note again, right? According to the Bohr theorem, there are 4 stipulates, so 4 statements. These are the 4 statements, or 5 statements. Blah, 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 blah. You know. So according to this one, this is also not rejecting nucleus concept. So because of that, this is a nuclear model, right? This is a nuclear model of the atom. Then number 2, from the Geiger-Marsden experiment, nuclear model or nucleus is proposed. The idea of the nucleus is proposed. එතකොට ආයේ වැල වගේ ඇදෙනවා. එතකොට මතක් වෙන්න ඕන okay what is the Geiger Master experiment? Then you draw a sketch here. Not එකේ මඳිනවා. මේ ලියන උත්තර answer sheet එකේ මඳිනවා. වෙලාව ගියට කමක් නැහැ. Right? So you draw the sketch. The gold foil is there, and the zinc sulfide plate or the cover is there, and you have a slit, and you have a radioactive element which is giving out alpha rays. Then you have a lead container, right? So it is giving out alpha rays. Most of the alpha rays, 99% of the alpha rays are moving across the gold foil without any deflections. 1 out of 1,000 is showing deflections, creating small angles. Then large angles, one out of 20,000, 1 out of 50,000 is coming back in the same path. So likewise, that's fine because you have now right now you have ample time. That's totally fine. So because of that, this is the first time that the proposed or the nucleus, the idea of the nucleus is proposed. So therefore, this is the point where the first nuclear model came into the concept or came into the world. ඔයා ලියන්න. ඔයාගේ භාෂාවෙන් ලියන්න. නෝට් එක බලාගෙන ලියන්න කමක් නැහැ. හැබැයි ගොඩක් හොඳයි if you not look at the note and write down everything. That would be the perfect way, right? Then it will test your recalling power as well. You can't recall the things. In chemistry, there are two things, right? First one is memorizing, other one is recalling. ඔය දෙකම බැලන හබක්. සමහරවිට මතක තියාගන්න පුළුවන්. Someone can memorize the things but can't recall, right? So recalling is also can be done, should be done. Otherwise, you can't answer the questions. So why I am asking you to writing down everything, it will improve your recalling power, right? Recall කරන්න කොච්චර ස්පීඩ් එකකින්ද කියන එකත් වැදගත්. That is also very important, right? So memorizing means when you are reading or when you are at the class, you are memorizing the things. That is absorption, emission, recalling, right? Both are needed. Otherwise, absorption විතර කරගෙන හරියන්නේ නැහැ. You have to take out the theory that you have recalled or that you have memorized whenever needed. That is why I am asking to write them down. This is one method. කම්මෙන්ට ලියන්න ඕන. ඊට පස්සේ තුන්වෙනි එක. ඒක ලියන්න තු ඉන්නේ නැහැ. ඒකත් ලියනවා. C. ඒක ලියනවා මෙහෙම. Electron do not behave as blah blah blah. This is wrong. Why this is wrong? Because at the same time it can show a momentum characteristics, or it can perform a momentum, and as well as it is having the frequency. It is having a velocity. So therefore, both of wave and particle characteristics can be shown by the electron at the same time. Therefore, this statement is wrong. ඕන නම් අර මොමන්ටම් එකේ අර තියෙන්නේ කොහොමද අපි පෙන්වන්නේ කියලා අදින්න cathode ray tube, how we confirm cathode rays are having momentum. There is a paddle wheel, and paddle wheel is moving. That's how we confirm the availability or the confirmation of the momentum. That is how we confirm that cathode rays can create a momentum. That's okay, right? Then you will recall the things. Then number D, EOM ratio. EOM ratio is same for any gas used inside the cathode ray tube, but this is not the same for positive rays. Positive rays shows different EOM ratios depending on the gas used inside the cathode ray tube. Right? Okay, අඳලත් පෙන්නනවා. ඊට පස්සේ EOM ratio එක මොකක්ද කියලාත් ලියනවා. For electron, EOM ratio is this one. So see how you cover a total theory part by using, like, you have covered a lot of theories there by using one question. This is how you recall, this is how you learn, this is how you do the things at home, right? පිටු ගානක් ගියාට කමන්නේ ලියන්න. මට මේක පුළුවන්, මේක උත්තරේ ඒක. ඒක වැඩක් නැහැ. ඒක තේරුමක් නැහැ. පාස් පේපර්ස් වලට උත්තර දැනගන්නවා කියන එක වැඩක් නැහැ. For me, it's not needed. Pass papers කරන්න ඕන, උත්තර මතක තියාගන්න කියන එක ඒක වැඩක් නැහැ. මේකෙන් ගන්න ඕනේ ඒක. හරිද? Then 8th question. So this answer is first one, right? So the 8th question. So this question is also like these are called as statement questions, right? So there are in usually these questions are given from 40th question to 50th question. Or කලින් කතා කරපුවා they are giving from 30th to 40th. So these type of questions are given from 30th to 40th. Right? Then the statement question. සාමාන්‍ය මේක past paper එකක වගුවක් වගේ තමයි දෙන්නේ මම මේක පෙන්නන්න. They are giving statement 1 and statement 2. Right? So let's say this is 41st question. The statement will be given like this. Then they are giving another statement. Right? So how you select the choice is if both statements are correct. If both are correct and second statement is explaining the first statement, then the answer is 1. Then if both are correct, if second statement is not explaining the first statement, then the answer is 2. Then if first statement is correct, second statement is wrong, answer is 3. If first statement is wrong, second statement is correct, then answer is 4. If both statements are wrong, then answer is 5. So see how much tricky are these questions? If first statement is correct, second statement is also correct. If second statement is explaining the first statement, then the answer is 1. If both statements are correct but not interrelated, right? That means second statement is not explaining the first statement, then the answer is second choice. Then if first one is correct, second one is not correct, then the answer is third one. If first one is not correct, second one is correct, fourth one. If both are not correct, then fifth one. මේ ගණන් හදන්නේ කොහොමද දන්නවද? You take the answer sheet. You take the answer sheet. Sorry, the question paper. Like let's say this is the table. This is statement 1. This is statement 2. කොළයක් අරගෙන මේ පැත්ත වහනවා. Statement 2 එක වහලා දානවා. ඒක දිහා බලන්නවත් නැහැ. There are 10 statements. 41st, 42nd, 43rd, 43rd, blah blah blah, 50th. ඔය ටික හරි වේදට දාගෙන යනවා. හරිද වැරදිද? Second statement එක දිහා බලන්නේ නැහැ. You are not checking the second statement. Then take out the paper. අර වහපු කොළේ අරගෙන first statement එක වහනවා. Then second statement එක හරිද වැරදිද දාගෙන යනවා. Without looking at the first statement or without recalling the first statement. That means the idea is individually, independently, you are checking each and every statement. Then after that, you take out the paper. දෙකම හරියව විතරක් අල්ලගෙන check කරගෙන යනවා whether the second statement is clearly explained in the first statement. There are very few instances where both statements are correct. දෙකක් තුනක් විතර වගේ. Then you are carefully checking whether the second statement is explaining the first statement. Then you check the answer. You get the answers like that. ඔක වහන්න නැත්නම් මොකද දන්නවද කරන්නේ? පළවෙනි කියන ගමන් while you are reading the first statement, second statement දිහා හොරෙන් බලනවා. ඒකත් හරි වෙන්න ඇති. මේක උත්තරේ 3 වෙන්න ඇති. ඒතර වැරදිනවා. right? පළවෙනි එක හරි ගියොත් එහෙම මාර ප්‍රශ්නයක් යනවා. Then whether the second statement is correct. Second statement එක correct වෙනවා නම් එහෙනම් මේක සමාන වෙනවද? ඔය වගේ මොලේ පොඩ්ඩක් මොලේ cheat කරන්න ගන්නවා ඔයාලව. Brain will start to cheat you. Right? That's why these questions are formed. The ability to check the questions or the answers independently. Right? ඔහොම තමයි මේ ප්‍රශ්න හදන්නේ. දැන් මේ මම දීලා තියෙන එක නේ ස්ටේට්මන්ට් එකයි තියෙන්නේ. ඒකට කියවක මහාම දෙයක් නෑ. හැබැයි පරිස්සමටක බලන්න ඕන. හරිද? Now how you take the choice if the first statement is you are checking first statement and second statement. If the first statement is correct, sorry, not the correct. That means this is the way that you are selecting the correct choice. හරිද? මේක මම දීලා නැහැ. මේ මට මේක උගන්වන්න ඕන ඉඳ තමයි මේක මම දුන්නේ නැත්තේ. ඔයාලට අටක් ගාලා මේක දාගන්න දැන් ඔයාලා මොනවා හරි මෙතන මේ නෝට් ඩවුන් කරගන්නවා නම්. හරිද? Eighth question. The atomic spectrum of hydrogen is a line spectrum. Atomic spectrum of hydrogen is a line spectrum. Make about that tricky. They are not mentioning about whether it is an emission spectrum or the absorption spectrum. Right? But they are referring to the emission spectrum. Otherwise, if it is referring to the absorption spectrum, that is also fine. But they are referring to the emission spectrum, right? So hydrogen emission spectrum is a line spectrum. That is correct, because you can see only few 4 lines there. Only 4 lines you can see in the hydrogen emission spectrum. So therefore, it is called as a line spectrum. Or sometimes this is called as discontinuous spectrum as well. It's not a continuous spectrum, it's a discontinuous spectrum. So another word for discontinuous spectrum, if they are appearing as lines, they are called as line spectrums as well. So the first statement is correct, right? First statement is correct. So let's read the second question. The energy associated with each line of the spectrum is equal to the energy of the electronic level corresponding to the line. The energy associated with each line of the spectrum is equal to the energy of the electronic level corresponding to the line. Is it correct or not correct? හරිද වැරදිද කියලා මට කියන්න බලන්න. chat එකේ දාන්න පුළුවන් නැත්නම් මට ඇහෙනවා ඔයාලා කියන එක. unmute කරලා කිව්වොත් කමක් නැහැ. මොකද හිතන්නේ ඔයාලා? What do you think? The energy associated with each line. That now the first one is correct. No, so it's a line spectrum. The energy associated with each line of the spectrum is equal to the energy of the electronic level or energy level. Electronic level like an energy level. It's another word corresponding to the line. They are saying the energy of the line is corresponding to the energy of the electron energy level. Line energy line is showing a color, means line has a energy. If line has an energy, they are saying this energy is corresponding to the energy level or electron level energy. Is it correct or wrong? නිදිනා නේද? උත්තරයක් ආවා. Good. දැන් මේක මෙහෙමයි. මම කියන එක ඇහෙනව නේද? හරි. So there is a line. These are lines, right? Let's say this is the hydrogen emission spectrum. We know in this direction frequency is increasing, right? If this direction frequency is increasing, we know energy is also increasing. In the frequency increasing direction, lines are getting closer. So this line shows you an energy. If it is having a color, the color is corresponding to a frequency. Since it is having a frequency, it should have a energy. So they are asking, what is this energy? මේ energy එක කියලා කියන්නේ මෙතන මේ එන the energy difference of the emission spectrum. In other words, this E means, let's say this is moving from n equals n to n equals n minus 1. So it is releasing energy equal to energy of n minus 1 minus energy of n, or other way around. Let's say n minus 1. This is equal to h nu. So this line energy is corresponding to the energy level, is not corresponding to the energy of the energy level. It is corresponding to the energy difference of the electron transition, right? So in emission spectrum or absorption spectrum, this energy of a line is corresponding to the energy difference between two energy levels, not the energy of one level or not energy of the final energy level, but it is corresponding to the energy difference between two energy levels, right? So therefore, the second statement is wrong. This energy is referring to the energy level difference of the electron transition, right? So first statement is correct, second statement is wrong. Okay, so the answer is number 3, third choice. So this is the theory. This is referring to energy of this line. ඔය ගණන් එහෙම මම හදලා තියෙනවා. අමරික උත්තරේ හරි. correct. So this is how we should deal with this one. ඔයාලා දැන් උත්තරේ මේක ලියනකොට මේ ඔය විදිහට ලියවට කමන්නේ ඔයාගේ භාෂාවෙන් ලියන්න. In your words you can write it down. Okay. Any questions on this one? මේක දැන් ඉගෙන ගන්න නැත්තම් කමක් නැහැ. මේ මම නිකන් හිතාගෙන ඉන්නවා මේ පළවෙනි පාඩම අහපුවායි නිකන් මරතන් එකක් වගේ දවස් 3කින් ඉවර කරන්න වගේ. මේ කව වෙලා නැති එක. මම දවස් 3ක් කියන්නේ. දවස් 2කින් හරි 3කින් හරි මම ඉවර කරනවා ෆස්ට් එක. ඒක නිකන් රැපිඩ් රිවිෂන් එකක් වගේ යන්නේ. එතකොට කැමති කෙනෙකුට ඇවිල්ලා ජොයින් වෙන්න පුළුවන්. එක දවසින් අපිට ඕන මෙහෙම කරන්නත් පුළුවන්. එක නයිට් එකක් වගේ ගහන්නත් පුළුවන්. මම ඒකට වැඩි කැමති නැහැ. උදේ 6 ඉඳලා sorry රෑ 6 ඉඳලා උදේ 6 වෙනකම් වගේ ඉස්සර දැන් ඔයාලට ඕනේ නැහැ. possible. Right, the next question, number 9. Read the question. Which of the following statement is wrong? That is also ABCD question, right? So let's take number 9, ninth question. No? Let's read the question. Which of the following statement is true? I get true එකක් දෙන්නේ. ඔව් යටින් ඉරි ඇඳගත්තට කමක් නැහැ. It's they are asking about true. Eighth part, sorry, A1. Positive rays are formed when an electron is removed from an atom or molecule in a cathode ray tube. That is correct. This is a theory that we know, because when hydrogen gas is within the cathode ray tube, first when high amount of voltage is applied, H2 gas will be converted to 2H gas. Then further gas pressure is lowered, and under high voltage, 2H gas will release an electron to convert into This is releasing two electrons to convert into H plus gas, 2H plus gas. So these are the positive rays. Positive rays are called as canal rays as well. These electrons are known as cathode rays. This is the chemical reaction happening inside the cathode ray when hydrogen gas is applied. So you need to have high voltage and low pressure for this one. Under high voltage and low pressure, these uh, characteristics or these reactions could be observed, right? මෙයාගෙන් මේක ගලවලා දාන්න ඉලෙක්ට්‍රෝන එක ගලවලා දාන්න. Now we know what are cathode rays and චූටි කාලේ දැන් විභාග මේ ඕලේ ඉවර වෙච්ච ගාම වගේ මට ඕන එකපාරම ඉලෙක්ට්‍රෝන ද cathode rays ද positive rays ද කියලා කියන්න බෑනේ. හැබැයි දැන් මෙතනදී අත්‍තරම වෙන්නේ when you have hydrogen, when you have chlorine, when you have any other gas, first it will detach the bonds because H2 is having a covalent bond. So with high voltage, now why we need a voltage to detach this one? Now, I'm asking additional question, right? Why we are not applying any other energy source? Why we choose the high voltage to detach this bond? What is the reason? The reason is very simple. Now, then හිතන්න දැන් මේ ඔය මොකක් කරේ yes මම උත්තරේ දාන්න රිකෝල් කරන්න එපා මට රිකෝල් මගේ වුලක් ගියා right උත්තරේ හරි ඔය දාපේ මෙහෙමයි then yeah correct your answer is correct නමුරු so දැන් හිතන්නකෝ කවුරු හරි කෙනෙකුට විසක් කැවිලා හරි විසක් අපි දැන් මොකද විස සතෙක් කාලා කියලා සර්පෙක් කාවා කියමු අපි නේ උදාහරණයක් විදිහට එතකොට ඌ අරගෙන හොස්පිටාලේ ගියාම කාපු එක අරගෙන හොස්පිටාලේ ගියාම බේතට දෙන්නේ විසක්මයි අර කියන්නේ විසෙන් විස නසනවා කියලා දැන් ඔයාලා කියවලා තියෙනවද මම ඉංග්‍රීසි නම දන්නේ නැහැ මොන්ත ක්‍රිස්තෝ කියලා පොත සිටුවර මොන්ත ක්‍රිස්තෝ කියලා තමයි මම සිංහල there are 6 volumes 6 books ඔය මේ මලියදේ විද්‍යාලයේ මේ ලයිබ්‍රරි එකේ ඉස්සර තිබුණ පොත් හයම දැන් තියෙනවද දන්නේ මම ඕකෙන් අරන් තමයි කිව්වේ පොත් හයක් තියෙනවා ඕකේ සිටුවර මොන්ත ක්‍රිස්තෝ කියන මිනිස්සයා සල්ලි තියෙන මිනිස්සෙක් පොර හැමදාම රිනයිට් ඉන්දියන්න කලින් විස කනවා පොඩ්ඩ කනවා ඒකට හේතුව හැමදාම බයෙන් ඉන්නවා උට විසක් කවලා මරයි කියලා කියන්නේ උට විසෙන් ඉස්සර මගේ ෆ්‍රෙන්ච් කතාවක් මොන්ත ක්‍රිස්තෝ කියන එක මේකේ ඉංග්‍රීසි නමක් තියෙනවා මට මතක නැහැ හරිද සිංහල කවි සිංහලෙන් ඔක ලස්සන මේ හිස්ටොරිකල් කතාවක් ඔයාලගේ ලිටරේචර් බුක්ස් වලත් ඇති සමහරකට මම දන්නේ නැහැ මනුතාපේ කියලා තමයි සිංහලෙන් මේ ඔය ෆිල්ම් එකේම ගියේ පොර විස නිදා ගන්න කලින් චුට්ට කනවා හැමදාම පොතේ තියෙනවා මුට ඇත්තටම විස දෙනවා දවසක උට මැරෙන්නේ නැහැ හේතුව උගේ ඇඟේ විස තියෙනවා ඒතර ඒ විසෙන් අර විස නසනවා හරි ඒක ඇටැක් කරනවා හරි මොකක් හරි උට දැන් පුරුදු වෙන වෙලේ ඒ වගේ හරිද ඒ කියන්නේ විසක් නසන්න විසක්ම තමයි දාන්න ඕනේ දැන් මෙතනදි වෙන්නේ the bond is also created through electrons electrons is also having electrons are the reason for the voltage right in physics you will be learning about electric fields but in your oral knowledge you know the voltage difference in the dipole is created due to the electrons so if you want to detach this electron bond you have to apply electron, so electron flow. That means you have to apply high kind of velocity, high kind of voltage, not velocity, voltage. Voltage is also kind of electron flow. So to break the bonds, you need to have a voltage or electron flow. That's the reason, right? Low voltage that's also separate scenario. We will be discussing those things when we are learning about the third unit, or sorry, fourth unit, the gaseous unit. Why the low pressure is used here. But why high voltage is used? Because if you want to break a bond, you can use electron flow. That is one method. So that's why high voltage is used here, because high voltage is also electron flow, high electron flow, because that is also generated due to the electrons. The in chemistry, if you are breaking a bond, high voltage is one method, right? So the first statement is correct. Positive rays are formed when an electron is removed from an atom or a molecule. Hydrogen H2 means a molecule in a cathode ray tube. That is correct. So A is correct. Let's say B. Cathode rays are originate from the cathode. Is it correct or wrong? Correct or incorrect? Cathode originate from cathode. කටින මොකද දෙන්නේ? මේක හරිද වැරදිද? බලන්න මේ අහන විදිහ. This is 2007 ළඟදී මේක අහලා නැහැ. අහන්න පුළුවන් මම දන්නේ. There is a practical, or there is a experiment that we draw in in the in our theory notes. We learn that cathode rays are generated from the cathode, and they are generated perpendicular to the cathode as well. So cathode rays are generated from the surface of the cathode, and they are releasing cathode rays perpendicular to the surface of the cathode. So how we analyze this one is by using a concave cathode, and you do the testing, and the cathode rays are moving from one point, right? So this is confirming that cathode rays are generating from the surface of the cathode, and also they are releasing, or they are emitting from the cathode, creating perpendicular angles or perpendicularly, right? So B is also correct. දැන් මේකට උත්තර ලියනකොට මේක ඇඳලා ලියුවට ප්‍රශ්නයක් නැහැ. හරිද? මේක ඇඳලා ලියන්න. ඔය ටෙස්ටිං එකෙන් ඇඳලා ලියන්න. Right? So let's say C. Positive rays are originated from the anode. මම මේක clearly කියලා තියෙනවා class එකේදී. Positive rays are not originated from the anode. Positive rays are generated in between anode and cathode, because H plus is not on the cathode, right? H plus is in between anode and cathode. So H plus are the positive rays. So therefore, they are originated not from the anode, they are originated not from the cathode, but they are originating in between the anode and cathode. So therefore, C is wrong. Let's check D. Cathode rays are type of electromagnetic. Cathode rays are a type of electromagnetic radiation. What do you think of this one? Cathode rays are a type of electromagnetic radiation. මොකද්ද මේ ගැන හිතන්නේ? මේක හරිද වැරදිද? මට බලලා කියන්න බෑ. Is it correct or is it wrong? What do you think? මේවා electromagnetic type එකක්ද නැද්ද කියන එක තමයි අහන්නේ. කට්ටිය කියන්න බලන්න උත්තරේ. Cathode rays are a type of electromagnetic radiation. Is it electromagnetic wave? Cathode rays? Okay. Now, can you recall the electromagnetic radiation or the spectrum? මේක මරු ප්‍රශ්නයක් නේ. ගොඩක් කට්ටිය මේක වරද්දගෙන තියෙනවා මේ පාර 2007. Can you recall the electromagnetic spectrum? Electromagnetic waves? We have gamma rays, we have X-rays, we have ultraviolet rays, right? Then we have visible spectrum, and we have microwave. We have radio waves. Have you ever seen cathode rays here? In electromagnetic spectrum, have I given that cathode rays are there? No, right? No, I haven't given. How the electromagnetic waves are generated? Electromagnetic waves are generated from the oscillation between electrons, sorry, the electric field and magnetic field. Can you remember? I have explained, I have clearly explained, right? So if there is electromagnetic or the electric field in this direction, if there is a magnetic field in this direction, in the uh, perpendicular direction, there will be a wave. So these are called as EM waves, right? Electromagnetic waves. So cathode rays are not generated due to the electric field and magnetic field. They are generated due to some other reason. Yes, true. It's a wave. It's a radiation, but it's not an electromagnetic radiation. So cathode rays is not electromagnetic radiation. Electromagnetic radiations I have drawn separately, right? I have told you like, yes, that's true. This is having a frequency. This is a wave. This is having a frequency. This is also showing some particle characteristics, blah, blah, blah. But this is not generated due to electric field and magnetic field oscillations. So this is generated due to the chemical reaction. It's an electron, right? So electromagnetic waves are not a part of cathode rays, or like other way around. So the cathode rays are not a part of electromagnetic waves. So the answer D is also wrong. මෙවම theory වලට කියලා දෙන දේවල් නෙමෙයි මේව ප්‍රශ්න කරලා ඉගෙන ගන්න ඕන දේවල්. After analyzing the questions, this is how you do the questions. Oh, sorry, how you getting to know some additional theories, right? Now, when you are answering this question, you draw the electromagnetic spectrum. You clearly mention that, okay, the cathode rays are not here. Electromagnetic waves are generated due to the oscillations between electric fields and magnetic fields, but cathode rays are not generated due to oscillations of electric fields and magnetic fields, blah, blah, blah. You mention those things, right? So A and B is correct. So according to our previous thing, if A and B is correct, where is it? Like here. If A and B is correct, answer is the first one, right? So our answer is first one. This is ninth question. මම recording එකක් දෙනවා මොනවාරි මිස් වුණොත් බලා ගන්න පුළුවන් ඈ. Right. Now let's go to the 10th question. 2008, that one. Which of the following pairs of lines have දෙකම දීලා තියෙනවා a difference or differences between them which is equal to that between the third means H gamma and fourth H delta lines of Lyman series of the atomic spectrum of hydrogen. Which of the following pairs of lines have differences between them which is equal to that between third H gamma and fourth H delta lines of the Lyman series of the atomic spectrum of hydrogen? You can see some problem in this question. Let me check the question. This is 2008. Yeah, you have to adjust this question. Give me first time आपका block किया ना. Let me repeat the question for you. 2008. Which of the following pairs of lines have differences between them, which is equal to the difference, which is equal to that between third and fourth lines of the Lyman series of the atomic spectrum of hydrogen. මේ H gamma H delta කියන එක අයින් කරගන්නකො එතනින් මේක නැත්තම් මේක පැටලෙනවා. Right? So they are asking in the hydrogen spectrum in the hydrogen spectrum, consider the Lyman series third and fourth lines, and consider the difference between those two lines, and which of the following are equal to that difference. That means Lyman series third and fourth line difference would be equal to which of the following difference or following lines differences. That is the answer. That is the question that they are asking. You consider the third and fourth lines of the Lyman series, and the difference between third and fourth lines would be equal to which of the following difference. That is what they are asking, right? So this is kind of a tricky question on this one. So you need to understand what is the third and fourth third and fourth differences, right? So third line and fourth line differences, what are those? You need to understand clearly, right? So let's consider the Lyman series. මේ ප්‍රශ්න ටිකක් පැටලෙන ප්‍රශ්නයක් මම මේක explain කරාම තේරෙයි. So Lyman series is created when electrons are falling into high energy levels to low energy levels, right? So this is the first line of the Lyman series. Let's say this is n equals 1, this is n equals 2, this is n equals 3, this is n equals 4, this is n equals 5. This is the first line of the Lyman series, right? So this is the second line, and this is the third line. Let's highlight this one. This is the third one, and this is the fourth one. So the difference between these two lines is this one, this gap, this energy gap. They are asking out of which gaps is equal to this gap. Right? So that means which line is moving between, or like which line difference is having the energy level difference between 5 and 4. So let's take one by one. First one is given as the third and fourth line of the Balmer series. Right. So let's draw the Balmer series. Let me separate one. So this is first line of the Balmer series. Second line. Third line. Sorry, and this is the fourth line. So in the Balmer series, this difference is belongs to This is the first one, second one, third one, and fourth one. This difference is equal to the difference between third and second lines, because this is the difference that we need to measure. Balmer series third and second one, right? Make it, you know, third and second one, C, right? C කියන එක හරිය. C is one of the answer. Because මේක partial series එකත් මේ වගේ අහනවා. හරිද? Partial series එකත් අපි බලමු කොහොමද set වෙන්නේ කියලා මේක. Partial series, let me draw in different color. So partial series means from high energy levels to low energy levels. So this is the first line, this is the second line, and this is the third line. This difference is belongs to partial series second and first line difference, or difference between second and first line difference, because the same thing happened here. So same energy difference, right? So partial series first and second line difference. So that is, in this question they are saying it is B, right? B එක තමයි එහෙම දීලා තියෙන්නේ. අනිත් ඒවා බලලා වැඩක් නැහැ, මේකනේ දැන් කියන්නේ. අනිත් ඕන නම් බලන්න. Third and fourth lines of the Balmer series, that is belongs to that is not belongs to this difference. And the other one is third and fourth lines of the partial series, that is also not belongs to this difference, right? So Lyman series difference between third and fourth lines, that energy level difference is equal to the partial series third and second line difference, and partial series Balmer series third and second line difference, and partial series second and first energy level difference. So that is, in an indirect way, that is, we are referring to the same energy level differences. That means energy level difference between n equals 5 and 4. So the answer is B and C is correct. So B and C is correct means A and B is 1, B and C is 2. So the answer is second one. දැන් මේක ඉගෙන ගන්න කාරණාවක් එක කාරණාවක් තියෙනවා. The how to denote the lines. First line means the lowest energy line always. ඒක කොහෙවත් කියලා දෙන්නේ නැහැ. මේක ඉගෙන ගන්න ඕන දෙයක්. Right? So in a series, the first, if you say like it is the first energy level, oh sorry, the first line means the lowest energy level. So in the Lyman series, this is the lowest one, right? This is the lowest. So the lowest one will be the first line. This is the second line. This is the third line. This is the fourth line. There can be more than that. That depends on the energy levels that we are considering. Balmer series I have marked it in this sketch, and the partial series also I have marked. So no, I have not marked. No, the partial series. So this is the number 1. This is number 2. This is number 3. So likewise, it moves on. So the lowest energy one will be marked as number 1, then number 2, number 3, number 4, blah blah blah. That's how it is moves on. So the answer is the second one. B and C is correct. Right? That is how you do the second question. Sorry, 9th question. Wait, sorry. 10th question. Wait, sorry, 10th question. Answer is second one. Okay. Make it clear now. Any questions on this one? Everybody understood this one, right? Okay, good. Next question. Statement question. 11th question. Yeah, electron behaves sometimes as particles and sometimes as waves. That is correct, right? Sometimes as waves, sometimes as particles. Behave, that is correct. Electrons have both particle and wave properties. That is also correct. Now tell me, does the second statement is explaining the first statement. That is my question. දෙකම හරි. The tricky point is whether the second statement is explaining the first statement. Yes, explaining. So electrons have both particle and wave properties. ඒක හින්දා තමයි sometimes it is behaving as particles, sometimes it is behaving as waves. So second statement is explaining the first statement. So both answers are correct. Second statement is explaining the first statement. That is obvious, right? Because uh, the electrons are behaving sometimes as particles and sometimes as waves because of the particle and wave duality. So therefore, answer is the first one. Second statement is explained by the first statement. First statement is explained by the second statement. Right. Okay. 12th question. මේක මං මේ විභාගයටත් මං දුන්නා මේ පාර මේ එක්සෑම් එක අපි තිබ්බේ ටෙස්ට් එක අපේ මේකලත් මේ වගේ එකක් මං දීලා තියෙනවා. A sample of hydrogen atoms excited in a flame has electrons distributed to n equals 1, 2, 3, 4 and 5 energy levels. How many different wavelengths of radiations are emitted by the sample according to the Bohr theory? Good question, right? Now, okay, maths කරන්නේ උන් දැන් කොහොම maths නේ කරන්නනේ. අමිත් වගිහිල්ලා. හැරිලා. හරි. පාඩමක් කරනවා probability වලට පස්සේ මම ඉතින් ඉංග්‍රීසි නම දන්නේ නැහැ. මට මතක නැහැ. සංකරණ සංයෝජන කියන NCR කියලා පාඩමක් කරනවා. ඒකේ question එකක් මේක. හරි. මේකෙන් හදන්න පුළුවන් මේක ලේසියෙන්. But I will explain it how to do it. So this is n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So when they are moving into high energy levels, they are moving from high energy levels to low energy levels, right? So they are saying the sample of hydrogen atoms. Sample of hydrogen atoms, we don't know how many hydrogen atoms are there. Some hydrogen atoms will move from n equals 1 to n equals 2. Some are moving from n equals 1 to n equals 3. So likewise, they have now in the high energy levels, it is moving according to the probability, right? So some part will move from n equals to that. There may be electrons in n equals 2. So there may be some transitions from n equals 2 to n equals 1. There may be some transitions from n equals 3 to n equals 1. N equals 4 to n equals 1. N equals 5 to n equals 1. So these are the radiations that we could see from high energy levels to n equals 1. ඕක පේන්න පුළුවන්. හරිද? හැබැයි මෙයා කියනවා electrons are distributed from n equals 1 to n equals 5. එතන උඩට ගිහිලා නැහැ කියලා අපිට කියනවා. It is given in the question. It is not moved beyond n equals 5 because the energy is supplied according to that. Then කවුරු හරි කාට හරි කෙනෙකුට හිතන්න පුළුවන් මෙච්චර lines ප්‍රමාණයක් කොහොමද වෙන්නේ? How these amount of lines are generated, because we are talking about a sample of hydrogen atoms. Some atoms may be moving from n equals 2 to n equals 1. Some atoms may be moving from n equals 3 to n equals 1. So likewise, there is a probability to move across these energy levels, right? So some electrons are moving from n equals 3 to n equals 2. Possible, right? So this is how it is creating the Balmer series, right? This is moving from n equals 3 to 2. 4 to 2. Sometimes it is creating the partial series n equals 4 to 3, 5 to 3. Sometimes they are creating a bracket series as well, right? So if it is creating a bracket series, it is moving from 5 to 4. So these are the all possible electron transitions, and these transitions are creating some kind of radiations, right? So radiation amount is, this is 4, this is 3, this is 2, and this is 1. So all together, it is creating 7, 8, 9, 10. So 10 radiations are possible here, right? Make a very well thing n equals 6 කියලා you have to consider n equals 6 as well. So then Lyman series will have transition from n equals 6 to n equals 1 as well. Balmer series will have n equals 6 to n equals 2. So likewise, bracket and partition series will be updated like that. Okay. So altogether there will be 10 transitions. මම මේ වගේම ගානක් මම අපේ මේ paper එකේ තිබුණා මම හිතන්නේ. මේ ගානම මතක නැහැ. So the answer should be the fourth one. The statement is fourth one. Sorry, the correct answer is the fourth one. The choice is the fourth one. So see how the questions are asked. Right? Let's take a look on 13th question as well. Okay, on and the Any questions? Ngerti ini mana ini? මේක මේ පාර්ටි එක හැරලා හැම ඉඳලා පුරුදු වෙන්න ඕන කට්ටිය මේ වැඩ ටික කරගෙන යන්න. නැතුව මේක අමාරු වැඩේ කරන්න. Right. Then the 14th question. A good question. This is 2010. A part of the emission spectrum of an atom hydrogen is given below. Part of the hydrogen emission spectrum. So this is a tricky point, like emission spectrum, right? Emission spectrum means electrons are moving from high energy levels to low energy levels, right? So always if it is an emission spectrum, the arrow should be downwards. This is emission spectrum because energy is emitted. Due to this emitted energy, frequency will be released. So emission spectrum, always the lines are from top to bottom. Right? If it is an absorption spectrum, energy is absorbed, right? Energy is absorbed. So the lines would be from low energy levels to high energy levels. So the arrows are upwards. So these are absorption spectrum. These are emission spectrum. Emission spectrums. So this is how we identify emission spectrums and the absorption spectrum in a energy transition diagram. So electron transition diagram or energy transition diagram. And also now they have given the lines, right? So the lines are A, B, C, D. So this A should have the highest frequency, B next frequency, C is next frequency, D is next frequency. So අපිට උදව්වකුත් දීලා තියෙනවා in this direction lambda is increasing means frequency is decreasing. So simply the frequency increasing order is A is the highest, so the decreasing order A is the highest, then B, C and D. අපි දන්නවා පුතේ when in a line spectrum, if the in a line spectrum, when the lines are getting closer in this direction, in that direction, frequency is increasing. Right? In the frequency increasing direction, lines are getting closer. Right? When the lines are getting closer, very much closer, the difference between the line gap is decreasing, then in that direction, frequency is increasing. Right? Frequency increasing means the energy is also increasing, right? So so lambda is decreasing in this direction, frequency is increasing, energy is also increasing. So energy is increasing means the energy increasing means the electron transition will be happening between high distance energy levels, because when it is moving away from the nucleus, the energy will be high. So I told you one line is representing the energy level difference. In a previous question, we have discussed that one. So that electron should move or should be transition, should be coming from very high energy level to the low energy level. Or in other words, the energy level difference between the two energy levels should be high. Then the frequency also will be high. So basically, A should have the highest transition. or the highest energy level difference. Yeah, good indoor. And also that is coming from high energy levels, low energy level, because this is an emission spectrum, not an absorption spectrum, right? So when you check in that way, so if you check like A answer, Arosa in the downwards, that is emission spectrum, but A is having the lowest energy level difference. It can't be. So first answer is wrong because A should have the highest energy and it should be moving. It should be transiting. It should be coming from very high energy level to low energy level. So energy level difference should be very high. The second one is also wrong because A is having low energy. උඩ දෙකක් අතර මාරුණා කියලා energy level difference is measured. So energy level difference is low in the second choice. And in the third choice, A is, even though that is coming into n equals 2, A is coming a larger distance. So it should emitting the higher energy. B next, then C, then D. ඒක නිකන් perfectly matching. හැබැයි අපි අනිත් ඒවාත් බලමු. The fourth one, that is also emission spectrum, but that is also wrong because A is having a low energy level difference compared to D. D is having higher energy level difference. So D should have the highest frequency according to the fourth choice, but it is not the case given. In the fifth one, that is also correct. Sorry, the energy level difference is correct, but it is showing an absorption spectrum, not emission spectrum. But the energy level difference of A is the highest compared to the D. But the energy level difference is highest. On the other way, it is an absorption spectrum, so therefore it will not work. That is wrong. So the answer should be the third one, because the arrows are downwards, that is showing an emission spectrum, and the A is having the highest energy level difference, and the D is having the lowest energy level difference. So that means D should have the lowest frequency and A should have the highest frequency. So that's how you analyze this question. මේ පාරත් මේ ගාන 2010 දී අවුරුදු 16කට කලින් ඔයාලට අවුරුදු 18කට කලින් නේ. ගොඩක් කට්ටිය වරදලා තිබුණා. Right? Many people have gone wrong in this question. Right. So we will stop the class from here for today. Let me stop the recording.